here. I'm just
So,
asking.
Topics 7, Section 1. This is not topic section 7, Section 1. If you go to your book and it's like, ooh, I need to watch a video that they have, this is not what you're going to find. Got it? But I named it what I did because I'm grabbing it from another textbook. Okay? So if you need extra help, you'll have the recording we record, but then you also will have to go find another one. Okay, so at the top, you might want a highlighter to highlight some things. I didn't make it fill in the blank. I just have it there. So vocabulary, if A and B are two numbers or quantities and B doesn't equal 0, then the ratio of A to B is A over B. I also could write that A what?
A is equal to 0.
No.
No, A dot.
A colon B. Okay? That is not the ratio, but is that the proportion? Yes, a ratio is a fraction. Okay? A ratio is a fraction. So this writes it as a proportion A to B, but a ratio. Any equation that states that two ratios are equal, such as A over B equals C over D, is called a proportion. The number B and C are the means. You got that yesterday, right? And A and D are the extremes. So you need to remember that. Part of your assignment is like the mean of the something means. Okay. The geometric mean of two positive numbers, A and B, is the positive number x that satisfies this equation. Okay, so A and B, see where they're at? A is in the numerator of the left, B is in the denominator of the right.
Is that how they always have to be when it's?
Well, we're talking about the number that's in this place right here and this place right here. To get the geometric mean always has to be those two numbers. Okay? So what we do with those two numbers, if you look at the equation, we would have, if I cross multiplied this, I would have x squared equals AB, right? Because x times x would be x squared, and a times b would be ab, yes? Then I take the what of both sides to get rid of the square. I take the square root. Everyone following? So the geometric mean is x equals the square root of a times b. So then the numerator of the left, times the denominator of the right is the geometric mean. That's something else you might want to highlight, right? Now, cross product. So if I have A over B and C over D, and B and D can't equal 0, why cannot B and E be 0? Yeah.
Then it wouldn't be a fraction.
Well, can I divide by 0?
No.
No. And a fraction's division, yes? I cannot ever divide by 0, so B and D can't be 0. I take the cross product. I take A times B and C times B, and they better be what? Equal. What we're really doing, guys, is just multiplying by the reciprocal. Is what we're really doing.
Do you want us to highlight that?
Yes.
What is that? I can't see.
Well, it's on your paper.
Well, I
It's
need
the
to see-
last
I need to
thing
see
on your
that.
paper. It's the last thing on your paper.
Let me see.
Okay, so I got this out of another book, and I'm like, okay, we'll just put it and see how it works. Put it up front. So that's all the vocabulary that we're going to use, so you will have to refer back to that. So it says simplify the ratios. 81 centimeters to 3 centimeters. So that is written with the colon form, yes? And to simplify it, I need to put it into a fraction. So this would be 81 centimeters over 3 centimeters. So the centimeters and the centimeters reduce, yes?
Yeah.
And does 3 go into 81?
Yes.
Yeah.
How many times?
27.
27. So So my answer is 27.
Centimeters.
Centimeters reduced. The centimeters reduced.
So you just
It's like
cancel this
science,
out.
guys. Railroad tracks and
Then
science.
you just cancel this out. then.
You reduce them out. You don't cancel. When
They're the same
cancel,
thing. You're
No,
getting
they're
rid-
not.
They're not gonna be
when
the same.
listen, canceling means it goes away, right? It goes away. So that would be 0.
So if they're the same.
There they go to 1. They reduce to 1. Why don't they reduce to 0? Because this is multiplication, then the whole thing would be 0, right? There's a difference between canceling and reducing.
That's what
These do not cancel. They reduce.
They're not gonna be there though.
They reduce to 1.
So then where do they
So
go?
this comes, okay, what happens is this becomes 1 and this becomes 1.
It's canceled out.
No,
It's not gonna be there for the 27.
I'm not ending this conversation. You will not use cancel because it's not correct. It is reduced. And you're going to take all of our note time up arguing something that you just have to get over.
I'm just saying it's canceled.
No, it's not. 1.
No, whatever. It's canceled. See it.
1.
Next one.
No. It
Are you
reduces.
serious?
Yes, I'm
Over me
serious.
just saying that's canceled. It's
Because
not
what
there.
does cancel mean? It goes to what?
It goes there. It's
It
it's
goes
gone.
to
Bye.
0.
See ya.
But it's not gone.
Then why isn't it down there then?
The centimeters is not gone. What did it reduce to?
Oh, I'm doing my assignment.
You don't even have it. The worksheet.
Hey, give me my worksheet, please.
1. You are
You can go on
punishing
to
everyone
B.
else because you
All
won't
right, go
listen.
to B. We can argue
No,
about this later.
we're
during
not
AP
arguing.
on my time.
1. The centimeters and the
All right,
centimeters
where's
reduce to
the-
what?
Like it-
What did they reduce to? 1. Okay. If I divide 3 by 3, what do I get?
What?
If I divide 3 by 3, what do I get?
1.
1. If I divide 81 by 3, what do I get?
27.
So what you are doing is 27 times 1, which is 27. And 1 times 1, which is what?
1.
1. When you say cancel, it means it goes to 0. If this were a 0 right here, what would the answer be? What if this canceled like you're insisting it does, that means it goes to 0. What would 27 times 0 be?
0.
0. Is that the answer?
Who said that we were multiplying 27 times 0?
Yes. Is 0 the answer?
No.
No. So it doesn't cancel. That is why it reduces.
I didn't know freaking canceling how to
Okay, that's all I'm explaining. That's why I explained it to you why we don't say cancel.
That's what I
Okay,
was taught.
next one.
Okay.
I have feet in what? Yards. I can't have feet in yards, can I? So this is your railroad tracks from science. We have to convert. So,
So does convert have a meaning as well?
convert.
It's canceled.
Okay, so I'm gonna probably turn yards into feet, right?
I
Because
turn feet into yards.
Feet are smaller and I have decimals and I don't have, we can do feet into yards, but I want to do yards into feet. How many feet are in a yard?
3,
3. Okay, so there's 3
45
feet in 1 yard. How did I know where to put those?
So you can cross them out.
Because, so I can reduce them. They have to be where I can reduce them, correct? Okay, so now I have feet and feet, which reduce to 1. Yards and yards, which reduces to 1. Anything next multiplies, correct? Up and down what? Divides. And we can reduce diagonally or up and down. Diagonally by 3 goes into 9, doesn't it? So 3 becomes 1, and 9 becomes what? 3. So 3 times 1 is 3. Oh, we're not done reducing. Can I go up and down? Yeah, 3 goes into 15, doesn't it? Okay, so 3 goes into 3 again. How many times? 1. 3 goes into 3, 1.
What are you doing?
I'm reducing. 3 goes into 15 5 times. So my answer is 1 times 1, which is 1, and 5 times 1, which is 5.
Would it be wrong if you write it with like the colon in it too?
If you would do what?
If you write it with the colon.
If
The yards
if
and
it
feet can.
started with a colon, And actually, I should have done that. Okay, just a second. Let's go back here. Thank you for asking that question. This is 27 over 1, yes? And it started with a colon, so should I put it back to a colon? Yeah, and I was wrong by not putting over 1 because we still have a ratio. So we should put it into what? 27 colon 1. Now, this one started as, B started as a fraction, so I leave it as a fraction. And guys, when I said I was wrong by just putting 27, when it's a ratio or a proportion, you have to show both the numerator and denominator. Make sense? Okay,
LP cancel.
So did you cancel those the yard?
Juan? And Bladen, if you guys insist, I'm kicking you out. I'm done.
I'm sorry.
Okay,
Alright, related.
now, the measures of the angle of a triangle ABC are an extended ratio. Okay, extended just means more than 2. The extended ratios can go forever. Got it? So we have a 2 to 3 to 5. So how many angles are in a triangle? 3. So how many numbers should I have? 3. I can do the same thing with angles as I do this problem with angles. I can solve a problem with sides exactly the same way. I can use it in a triangle, a rectangle, anything. Got it? Okay, so I'm going to draw myself a picture of a triangle. Mine usually look like a right triangle, but it's not. It doesn't tell me it is, so don't assume it is. Got it? So we probably should make sure that we don't make it look like a right triangle, right? I try, and they always tend to. See, I did it again.
Oh, that's a right
You're drawing a
triangle.
real triangle?
I'm just drawing a triangle. Just draw a triangle. Just don't make it a right triangle. Okay, there we go. And label it ABC. It doesn't matter if yours looks like mine. It doesn't matter.
Yeah,
Okay.
so what's it?
I know. I'm
Why
trying.
don't you just do the base?
Okay, so here's a triangle, yes? And my proportion is 2 to 3 to 5. And that means I can multiply any number by 2, 3, and 5 as long as it's the same number and I'm going to get the same ratio, right? So I'm going to put 2x and 3x and 5x. Now, the reason I started with A is because it's labeled A, B, C, yes? So my assumption, it's written in what order? A, B, C. Got it? So, what do I know that all of those add up to be? 180. So what should I do with all of those? Add them all up and equal to 180, right? Same thing we've been doing, haven't we? So 2x plus 5x plus 3x equals 180. Because I know all the sides in a triangle add up to what? 180. I said sides and I should have said angles. Okay? So if it's something with the sides, it would have to tell me like the perimeter, wouldn't it? Okay, so how many x's do I have?
You have
Oh,
3.
never mind.
There's 3 X's there.
No.
Yeah,
10.
count them. 1,
There's
2,
10
3.
x's.
Where are you getting the 10 from?
There's
Add them all.
2 x's here. There's 5 x's here.
Oh.
And there's 3 x's here. So how many x's do I have? 10. So 10x equals 180.
Then divide it.
And then divide it by 10, right? So what does x equal?
18.
18. So what are my angles then?
18
Nope.
degrees. Well, you gotta put x 18 into
18 in for this x.
18 for 3 X.
18 times 2 is 36 degrees. Right? 18 times 2. And then 18 times 3. So 3 times 8 is 4, carry 2, so 54 degrees. And then 5 times 8 is 40, carry a 4, 9, 90?
Yeah.
And 90 degrees. So is it a right angle, a right triangle?
Yes.
Yeah, but did we know that?
No.
No. Have we done problems basically like this already?
No.
Yes, we have.
Which ones?
Like this. We've done this before. They just haven't told us in terms of proportions, have they? Okay, so Yours was much nicer than mine is. Okay, try this one on your own. So 60 miles divided by 51, and not divided by, sorry. 61 miles, or 60 miles to 51 miles.
Can you even reduce that? Yeah.
They're both divisible by 3, add them up. 5 plus 1 is 6, right? Use those divisibility rules. Okay, Blaine, what did you do first on number 1?
I divided 51
By 3. And you guys remember your divisibility rules, right? If it's even, 2 goes into it, right? If you add them up and the number you get of adding up the digits is divisible by 3, the whole thing's divisible by 3, correct?
So
And 5 plus
where
1
would
is 6, and 3 goes into 6.
Where would that 3 go then?
Well, he's going to divide. If I divide 60 by 3, you get 20, correct?
Yes. And then
Okay. And you have to divide 51 by 3. So 51 divided by 3
17.
is 17. The 3 doesn't go anywhere. You're dividing by both of them by 3. Okay? Now what?
That would
Get rid of your miles.
My miles reduced to 1. So 20 times 1 is,
20.
and 17 times 1 is 17. So it reduces to 20 over 17. Okay, so the next one, what do I have to do to that first?
You gotta change the. Put it over.
I gotta make it a
fraction.
fraction first, then I gotta change units, right? Okay, so I have 7 centimeters over 14 centimeters. How do I know, 14 millimeters. How do I know that the centimeters goes on top?
Because it's the first one.
Because it's the first one, right? Okay, so millimeters are smaller than centimeters, right?
Yeah.
So let's change it that way. So how many millimeters are in a centimeter? So 1 centimeter,
70,
how many?
70 millimeters.
Can you give me
10.
some like science notes for this?
Millimeters. They're ones you should know.
I don't
Okay.
actually really know these.
Then you'll have to look them up. Okay,
Too good for
so
that.
I have my conversion now, right?
Yeah.
If I had to go further, I'd keep going until all of them reduced. So the centimeters reduces to 1, and the millimeters reduce to 1, and I can reduce up and down and diagonally, correct? Okay, I always look up and down. Can I go up and down?
Yeah.
Yeah?
1
7 goes into 7 one time, right?
and 2.
7 goes into 14 2 times. And now
You can do 2 and 10.
I can do 2 and 10.
What are you doing?
I'm reducing, I'm dividing. 7 goes into 7 once, 7 goes into 14 twice. Okay, and then 2 goes into 10 how many times? 5. Okay, so in my numerator I have 1 times 1 times 5 times 1 gives me what?
5 over
5. And my denominator is 1 times 1 times 1 times 1.
But
1.
then you have to put it in the
And I have to put it back into the colon form. Why? Because it started like that. So it's 5 to 1.
If I got the same answer but didn't do it like the same exact way as you,
It's fine.
Doesn't make sense.
Okay, so, and if you guys think this is a lot like your science when you did conversions with science, right?
I don't remember doing
You don't remember doing that?
I remember
I don't
doing
even
it
think
last
we
year,
ever
but I
did.
don't remember how to convert.
Okay. They're very basic ones. I think you go centimeters to meters, maybe. Is the biggest one. How many centimeters are in a meter?
10. That's all
There's 10
always goes
millimeters
by-
in a centimeter.
Yeah, and it
It's
always
always
goes by-
powers of 10. It's 100.
Oh.
Okay. Centa, that's why it's centa. Centa is a century, which is 100 years. Right?
Yeah.
That's how I remember it. Okay, so now I have a triangle, so I probably should draw a what? Triangle. There, I did it better. And this triangle doesn't tell me A, B, or C, but I just have to go around. Okay? So I'm going to label it what? 5x, 9x. I probably should have made a bigger triangle, huh? And what? 16x. What do I know that all those add up to be? 180. So do it. You should have enough room over here. I gave you guys more room, didn't I? Probably not. Did you get x equals 6? Okay, so x equals 6. What do I do with my 6?
Put it back.
Put it back in. So I get what? 30 degrees. 54. I thought you said just 4. I'm like, no. And 96. And if I wanted to check myself, I would do what? Add them all up and make sure they equal 180. And do that. 4 and 6 is 10, right? Carry a 1, so that makes that a 10 for the 9, and I got 8 for 180. Questions, guys? Now, they're going to give you like rectangles with perimeters. If I gave you a rectangle with a perimeter, I would just put the sides, right? Equals the perimeter, wouldn't they? Okay, so if I have sides, I have to have the perimeter, yes? If I have angles, I know that every triangle adds up to what? 180. I know every quadrilateral interior angles add up to
360.
360, so that I have to use facts I already know for the problem, right? Okay, so solving a proportion. So I put the steps here. So what's it say? Write it as a proportion. So if they gave you in colon form, you should write it as a proportion, right? So just write it out. Okay, do what then? Cross multiply. So this says I should do 4 times x equals 8 times 5, right? So 4x equals 40,
Then divide by 4.
and then divide by 4, not x, just 4. So x equals 10. Now, could I have, because remember I said if x was in the numerator, you didn't need to do the whole thing, did you? Could I just multiply both sides by 8 over 1? Could I have done that? And then 4 would go in here twice, and 5 times 2 is 10. So if x is in the numerator, can I do that?
Yes.
Yes. But if these confuse you, you should do cross product every time and you'll never mess it up. Got it? Yes, Cole?
Can't use the restroom.
Yes. Well, in this, the geometric mean, you want to stay for that real quick?
No, I'm fine.
Okay, so geometric mean, look at the front. What equation did it tell you for geometric mean?
Of 2 positive numbers, A and B is the positive.
Right, but what's their equation? X equals what?
AB plus square root of AB.
X equals what? Oh, you just said it. X equals the square root of AB, right? And guess what I put right here again? Okay, A and B, where's A? Where's A from? Where do I get A from?
You put it across the extreme.
So A is the the numerator, right? Oh, they just say, okay, I'm sorry. They just say find the geometric mean of 45 and 5. They didn't give me fractions, did they? They just gave me 45 and 5. Does that make sense? So I just do that. That's assuming that's my A and my B. A and B, sorry. Okay, so what do I do to them? Square root, right? X equals the square root of 45 times 5, right? Okay, well, the square root still. 5 times 5 is,
25.
okay, so 5 carry a 2. 5 times 4 plus 2, 22. Oh, here's the number you should know. What's the square root of 225?
25.
25.
15.
15. Okay, so the geometric mean is what? 15. Now they can give it to you like that, or they could give you like a proportion equation, and you would do the top numerator at the left and the denominator at the right, and stuff like that. Okay. So what am I going to do to solve every single one of these proportions?
Well,
You're going to cross multiply, right? What are you going to do to find your geometric mean? Multiply them together and take the square root, right? So do you guys want to try these on your own? Okay. If you want to do them on your own, do them on your own. Tyson, help me out with this one. How do I solve it?
All times 5.
How do we do the other example?
I know how to do it.
Oh. Am I okay to start?
Yes.
Okay. Vaughn, can you pick a mask out for your nose, please? Do you need help with them?
Yeah,
Okay,
possibly.
so we'll do 5 together. Okay, so what should I do on 5? How did I do 4?
Multiply stuff. There you go.
I multiplied 3 times A and I multiplied what? How'd I get 60? Okay, so over here, what are you gonna get?
So it would be like 30 times 7.
Yep.
It would be 210.
So 6x equals 210,
Yeah.
and then you divide by what?
6.
6. And I think you should get 35.
Yeah.
Okay. Anybody else want me to walk you through one? How did we do on 4 through 6?
Good.
Sound good? Okay, so now you're gonna find your geometric mean.
So for number 8, can you do 5 times like 40?
You have to do 5 times 40, that's how you do the problem.
I didn't know if you had to do 40.
You have to set it up like you do.
What do you mean?
40
That's
times 5.
That's, how did you do it?
I just did 40 times 5. Do we have to do the square root?
Yeah, you have to do the square root, that's the equation.
Yeah, no, like 40 times 5. I put it
Oh,
there.
could you just do the square root of 200?
Yeah.
Yeah, but that's
Why
not
is there
done.
not a 200?
I'm confused.
What did you just say?
Why is there not a square root of 200?
There's not a square root of 200, but is there a perfect square in 200?
20,
No, 20 is not a perfect square.
10.
10, 100, right? Isn't 200 2 times 100?
Yeah.
Okay, so what's the square root of 100? 10. And 2 can't do anything, right? So it's 10 square root of 2. You have to go back and remember how to do that stuff. We're going to be doing a lot of that next topic.
It's not.
I got passed this semester. Great. Square root of 90.
Okay, so 90, what's my perfect square of 90?
9.
9 times 10, right? And 10's not perfect square, there's no perfect squares in it, is it?
So 9.
So what's the square root of 9
It'd be 3.
and the square root of 10? So the square root of 9 is 3 square root of 10.
Why? Because it's on the outside one.
Oh, because we had 100. This was 100 times 2. Okay, so your assignment today is, these go pretty quick, right?
Yeah.